Over the past few years, I've seen countless software engineers recommend building from scratch as a way to level up your programming. After spending the last year building my own engine, I can confidently say that I agree. Not because building an engine is some secret shortcut, but because it's one of the few projects that forces you to practice almost every important area of software engineering. Here are the biggest reasons why. You stop depending on frameworks. A game engine doesn't come with solutions. You have to create them. You build your own rendering system, input handling, asset management, scene management, serialization, and countless other systems. Instead of learning how to use someone else's API, you learn how to design APIs that other people could use. Your software architecture improves. An engine quickly grows beyond a simple project. As more systems are added, good architecture becomes essential. You learn how to separate responsibilities, reduce coupling, create reusable modules, and design systems that can continue growing without becoming impossible to maintain. Those skills transfer directly into every other software project. Game engines interact closely with the hardware. Building one teaches concepts like memory management, CPU caches, multi-threading, graphics pipelines, matrices and transformations, resource loading, and file systems. These are fundamental computer science concepts. Performance becomes second nature. Real-time applications expose inefficient code immediately. You will develop habits like profiling before optimizing, reducing unnecessary allocations, improving cache locality, eliminating expensive algorithms, and measuring performance instead of guessing. Those habits improve every software you write. You become better at debugging. Engine development produces difficult bugs like rendering glitches, memory corruption, synchronization issues, and resource lifetime problems. Tracking these down requires patience and a systematic debugging process. Over time, you become much faster at identifying the root cause of complex problems. Many programmers spend most of their time working on isolated features, while engine development forces you to connect many subsystems. Rendering communicates with assets, assets communicate with the file system, physics interacts with transforms, and audio depends on timing. You gain experience managing a code base where every decision affects multiple systems. You learn to read graphics, APIs, compiler documentation, hardware specifications, and technical papers. Reading and understanding complex documentation becomes part of your workflow. Building an engine gives purpose to mathematical concepts like vectors, matrices, linear algebra, interpolation, quaternions, and collision detection. You're using math to solve real problems. Very few engine problems have step-by-step tutorials, so you spend time researching, experimenting, testing ideas, and refining solutions. That process develops confidence in solving unfamiliar problems independently. After building an engine, other programming tasks feel much more approachable. Whether it's back-end development, desktop software, graphics programming, or game development, you've already solved foundational system design problems. That experience carries over into everything else you build. Will building a game engine make you a better programmer? I believe the answer is yes. Not everyone needs their own engine, and commercial engines are not bad. But because building one develops skills that apply far beyond game development, it teaches architecture, performance, debugging, computer science fundamentals, system design, and problem solving. Those are skills that make you a better programmer regardless of what you build.